All right, here we go. We're to be working with bisectors in triangles. So I'm going to jump to here, and here we go. So basically, what's going on here is a sporting goods company has three stores: store A, store B, store C. It wants to build a distribution center so the distance from each store to the distribution center is as equal as possible. Where should they put the distribution center? Should it be where it is right now? No. Should it be somewhere about there? About right there. There? Somewhere around right there? Okay. Let's see how close we are. How can I tell how close I am? Well, if I grab my compass and I grab my straight edge, I'm actually going to grab my straight edge first. I'm going to make a triangle between A, B, and C here. So, bad marker. This one. Okay, so there's a triangle. Now what I'm going to do is take my compass and find the perpendicular bisector of each side. I'm going to go there. I'm going to go C. And draw in its perpendicular bisector. Then I'm going to take OB, because this is from A. So if I go to B, and I do the same one, I go right there. Right there is supposedly an equal distance from each store. Why would that be an equal distance from each store? Well, that's called the circumcenter. And when we were drawing last time, I put my pointer here and try to draw through each one. See how I miss B by a ways. Okay? But if I go down here, see how if I draw a circle, it goes through each of them. So, if I turn on my miles right now, this is 8.48 miles, this is 7.34 miles, this is 9.28 miles. But if I drag my dot down to where my other one is, right there. 9.13, 9.15, 9.41, so it should probably be this way just a little bit. About there. Okay? That is an equal distance away from each one. Now, that's an equal distance away, not right in the center of each of them. Okay? They said as equal as possible. Okay? So that's the same distance from each of the stores. Now, if I wanted to be in the center, that wouldn't be the perpendicular bisectors. That would be the angle bisectors. Let's see if I can draw up some angle bisectors here to this triangle. Now, the angle bisectors won't be the same distance from each door, but they'll be in between everything. Okay, so draw an angle bisector here. Pointer here, boom, hit that side, boom, hit that side, boom. That looks like a pretty good angle bisector. Now if I do another one from B here, really tough to do for B, but B is there, so right there, and you're going, whoa, that's not in the middle. Well, what happens is the angle bisector is the same distance from each side of the triangle. It's not exactly in the center, okay? So there's also called a median, and the three medians of a triangle hit in the center of the triangle called the centroid. So it all depends how you define what you're doing. So they said equal distance. Well, if you want the equal distance, you'll be right basically where these two roads cross. Okay, that'll be an equal distance from all of them. Okay, so perpendicular bisectors are equal distance from the corners of a triangle. Angle bisectors are an equal distance away from the sides of a triangle. That's something very important to know. So, perpendicular are equal distance from the corners. So if these are all perpendicular bisectors, this is 5.45 from each corner. So when things are equal or when things cross in the middle of a triangle, they are said to be concurrent. So these are a bunch of vocab words I'll let you write. When three or more lines intersect at one point, the lines are concurrent. So concurrent is when three or more lines intersect at one point. And the point of concurrency is where the lines intersect. Okay, so we have four different sets of concurrent lines. We have perpendicular bisectors that are congruent, and they form a circumcenter. We have angle bisectors that are concurrent, and they form what is called the incenter. We have medians that are concurrent, and they'll form a centroid. And then we have altitudes that are congruent, and they form what is called an orthocenter. We'll get to the other two on Friday. But today we're going to worry about the circumcenter and the incenter. So when you draw three perpendicular bisectors, they meet at what's called the circumcenter. And the distance from the circumcenter to a vertex, all three vertices are the same. So that's how when you drew your circumscribed circle yesterday, you should have put your pencil right on the vertex and drawn your circle. Okay? And then it should hit each vertex if you draw them right. Okay? So that is called the circumcenter. The point of concurrency of three perpendicular bisectors is the circumcenter. So basically from the word circumcenter, you can tell that the circumcenter is the center of a circumscribed circle. So it's the point of concurrency of three perpendicular bisectors. Point of concurrency of three perpendicular bisectors. A city manager wants a new emergency siren that's the same distance away from the school, the hospital, and the rec center. Where should the emergency siren be placed? Well, if it's the same distance away from each, you'd connect the three of them. You'd connect the three spots with a triangle. And then you draw perpendicular bisectors, and then where they cross should be the location of the siren. So in this case, the siren should be right at E, right in front of whatever building this is, okay? Because it's the same distance from the hospital, the rec center, and the school, okay? That would be the circumcenter. What's the coordinates of the circumcenter of this? Now, perpendicular bisectors. When you have horizontal and vertical lines, it's really easy to find perpendicular bisectors. Well, what's perpendicular of a horizontal line? A vertical line. What's halfway in between 4 and 0? 2. There's your perpendicular bisector of that side. Halfway across, perpendicular. What's halfway in between 0 and 3? 1.5, so 1.5 I draw. Where they cross right here, the coordinates of the circle, or the coordinates of the circumcenter is 2, 1.5. Okay, halfway between here, halfway between here. Angle bisectors are kind of similar, but instead of being equidistant from the four corners, as we saw in that earlier example, this is a lot further from this than it is from this. Okay, it's equal distance to the sides. So what happens is this is how you make an inscribed circle. Is you draw three angle bisectors, and that's the same distance away from each side. That's how you can inscribe the circle. So a circle that intersects each side of a triangle in exactly one point and has no points outside the triangle is called an inscribed triangle. That's the next vocab word. Sawyer Haig. Vocab word. Okay, so a circle that intersects each side of the triangle at exactly one point is an inscribed circle. That's where the incenter then is the point of concurrency of the three angle bisectors. So your angle bisectors go here, here, and here. They all meet at one spot. It's called the incenter. The point of concurrency of the angle bisectors is the incenter, because the incenter is the center of the inscribed circle. So, if from the inner center to this side of the triangle is 2, then from the in center to this side of the triangle would also be 2, and from the in center to this side of the triangle would also be 2. So 2, 2, and 2. Okay, they're equal distance away from the sides of the triangle. So it says QP is 3 times x plus 1, RP is 5x minus 3. What's the radius of that circle, of the inscribed circle? Well, these have to be, they're both the distance away from the edges of the triangle, so they have to be equal to each other. Okay, because they're part of an inscribed circle. So 3 times x plus 1 is equal to 5x minus 3. So 3x plus 3 equals 5x minus 3. What will you do to each side? Subtract 3x. So 3 equals 2x minus 3. Add 3. 2x equals 6. So x must equal 3. If we stick 3 in here, 15 minus 3 is 12. So this would be 12, and this would be 12. If JLP is 32 degrees, JLP is this angle right here. You need to understand how they name angles, okay? JLP means angle A down here, okay? That goes from here to here to here. It's not all 3 sides of the triangle. It's angle JLP. J to L to P, the middle letter is the angle that we're talking about, okay? JKL, this whole thing up here is 86. What's PJL? PJL. Okay? Well, if this whole thing is 86, what's this whole thing? Well, it's 32 plus 32. Because it's an angle bisector, so it makes 64. What's 64 plus 86 add up to? 150. So this whole thing is 30 because there's 180 degrees in triangle. So each part of it would be 15. How big is PJL? Well, it's 15. Okay. Breaking down that. Okay. So that's it for that. Now, some of you are saying, when would I ever use this? Well, Mr. Bierschbach actually used this last year because I'm in charge of region wrestling tournaments. And I actually used this type of stuff for setting up the site for the region wrestling tournament last year. So if I go to sent items, this is back in probably April, region, oh, come on, region, girls, boom. See if I can see it in my sent item. All right. See if my attachment's here. Oh, I think I saw my map. There we go. So I would, yeah, go big. Good job. If I go even bigger here, will it work? Come on. Oh, well, we can see from here. Okay. Oh, and then I lost it. Let's try this one more time. So where was that map? I know I had the map right here. So Try again. Okay. But it's not showing my map again. I was so proud of the map I made last year and that I used geometry for it. But now it's not coming up. So let me go down a little ways. Girls region next year. Girls region next year. There. Nope, that's region track. Dang it. Okay. Well, sent item. One more try. No, I don't know. I don't know what I did with that. But you can see the map of South Dakota. The region goes all the way from Gettysburg, all the way up to Sisseton, and all the way down to T. So I put those 4 schools on the map. I drew a triangle between all 4 of them, then did the perpendicular bisectors of each side of the triangle, and the closest town that was to that circumcenter was Clark. Guess where Girls Regions is this year? Clark. Exactly. 3 points. If I said 4, I was totally wrong. 3. Between 3 towns. Because Sisseton was the furthest one way, and Gettysburg was the furthest another way, and T was the furthest another way. So, yeah. So, I'm sorry, but I'll have to bring up that map in the future sometime.